Hey everyone, it's Mr. Canfield. Today we are going to be doing AB Calculus, Chapter 17, Part 2, Straight Line Motion. Okay, so if you're in physics, or if you've taken physics, you might be aware of a position function. And the position function that you have probably seen before is, I don't know what you'd use over here. Would you use like y of t? Or you might even just say p. When you're talking about projectile motion and you're talking about a ball going like up and down, or a pellet going up and down in the air, you've probably seen something like minus 4.9 t squared plus v naught t plus s naught. Shoot, s is p, right? Or maybe you're using y and it's y. Anyway, we generally don't use this in this class. We are going to use the imperial units. So, all right, enough weird language. Those of you that are not in physics, what I'm talking about is there's acceleration due to gravity on the planet Earth, and we pretend that it's uniform. It's not. Essentially, the idea is no matter where you are on Earth, you basically fall at the same rate. And that's if you pretend that there's no wind resistance. Yeah. So things that affect gravity, things that affect how fast we fall are things like air resistance. Additionally, though, how far you are from the center of the Earth actually determines how fast you fall. It's essentially something that we can ignore. And for an introductory course like AB Calculus, or like physics that you take in high school, we just pretend, yes, anywhere on planet Earth, it's the same. Okay, so all that out of the way, and this out of the way. This comes from, there's, this front number here is actually a over 2 t squared. So let's talk about this function really quick. And I'll use s, since they use s in here. So the position of a particle or whatever at any given time is half of the acceleration due to gravity, in our case of thinking about going up and down, half the acceleration due to gravity times time squared plus v naught. And we say v naught, this is 0, right? And it's a little sub-zero. So it's v with a little 0. And it's just saying our initial v, our initial velocity, our initial fastness times t plus s naught. And naught is literally like the word not. And people who speak British English, they actually, instead of saying 0, they generally say not. But it'll be with a British accent, so this would be like v naught. But that's why we call that v naught. Okay. But I'm not sure if it's not or not. All right. Okay, so anyway. Okay, so our position function that we are generally going to deal with is, and we use s for position because, I don't know, s of t. So we're going to deal with feet. Here's the thing. Acceleration due to gravity on planet Earth is essentially negative 32 feet per second squared, essentially. So half of that is 16, so negative 16 t squared plus v naught t plus s naught. And so this is going to be the position function that we use. I'm always going to give this to you on a test or a quiz, and on the AP exam they're going to give it to you. Stu doesn't always give this to us, so just keep this in your back pocket. Hey, what's the derivative of this? The derivative of position is velocity. Well, let's see, so that's negative 32 t plus v naught. Okay, so v naught and s naught, those are numbers. They're like our initial thing. We're going to plug them in at some point. Oh, the derivative of a number is 0, so it's gone. What's the derivative of this? Well, the derivative of velocity is acceleration. It's negative 32, t goes away. Oh, that goes away. Here's the thing. If you are taking physics, some of the calculus that we do, try doing derivatives on some of the equations that you've gotten and see if there's any relationships. There's some really cool stuff hiding in plain sight in physics that, since it's not a calc-based course in high school, you don't notice it and you don't see it. Okay, so using these, we can do some like particle analysis. You know, we can find out, or sorry, let's figure out things about a ball. So, question 5. A ball is launched vertically from ground level. Oh, I already wrote something there. 0. I actually already did this problem. I think I did it last year when I was filming, and you don't need to know that. Okay. So, with an initial velocity of 112 feet per second. Okay. So, like, I could even immediately know the position function, but let's see. Find the velocity and speed at t equals 3 and t equals 5 seconds. All right, finding speed and velocity. Oh, I actually do need the position function. Okay. So they're only ever going to give us the position function. So it's important for us to know how to set this up. Well, okay, well, my position, negative 16t squared. What's my initial velocity? That's what v naught is, 112. And then S naught is ground level. So ground level is 0. Okay, that's, oh, so I don't need to write that. Cool. So we want to find velocity and we want to find speed at t equals 3 and t equals 5. Okay, so if I want to find velocity, oh, I just take the derivative of position. So that means that v of t is equal to, that's going to be what, negative 32 t, and then that's just going to be 112. Okay, so what's my velocity at 3 seconds? So I just plug in 3 here. I'm not doing that. No, that's easy. Come on, Canfield. 3 times 30 is 90. 3 times 2 is 6. So 96. So the velocity is, oh, negative 96 plus 112. Which is, let's see, if I add 10 here, that's 106, and then 6 more. So 16, difference of 16 between these two. Okay, so that's equal to 16. Speed, okay, this is a little challenging. The way we find speed, if we know velocity, is we take the absolute value of that number. Oh wait, that was really easy. So I know before, finding out if we're speeding up or slowing down, that's challenging. That's where you have to check the signs versus each other and use the sign chart. But if I want to know the actual speed at any given time, that's easy. You just click the radar gun on it. Boom, done. So what about t equals 5? So same thing, negative 32 times 5, right? And then add 112 to it. All right, 32 times 5. Well, this is 30 and it's 2, right? So 30 times 5 is 150. 2 times 5 is 10. So that's 160. So negative 160 plus 112. All right. So what is that? 48. But it's negative. So we're going to talk about what these numbers actually mean in just a second. Because I want to make sure you understand the concept. It's important. All right, speed. Super difficult calculation time. Oh, I'm done. Okay. And if they give me units, they do. Feet and seconds. So these are all in feet per second. Boop, 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 boop. Okay. So what does this mean? So at 3 seconds, if we took, you know, I like to use the example of the police with a radar gun because many of you are driving now and you may have seen this even if you're not driving. You're on the road sometime and you see, you know, police officers standing there with the radar gun just pointing it at cars and they're just clicking it. And every time they click it, it's sending them a number. I'm guessing at least, maybe it's always on, but like it's sending them a number and it's sending them the speed of that car. And sometimes that speed is going to be the same as the car's actual velocity. sometimes that speed of 48, it's actually a negative 48 if we look at the velocity. And so this is where, like, if you're going toward or away from the police officer, it's going to show that 48. So speed is like a less descriptive velocity. It's like saying, I don't care which way you were going 48, and that's entirely too fast. I was going negative 48. Yeah, you're going 48 away from me. Good for you. That's still too fast. All right. So let's see. Oh, this is vertically. So this is like, so this means it's going up. This means it's going down. All right. How high will the ball rise? Well, let's think about that. What happens to the ball? The ball starts, let's see, let's grab a ball. Here's a ball. Ball goes, throw it up in the air at 112. What happens? It goes, slows down, and then falls. So where's the highest that it gets? We don't know, but we do know, based on our initial equation here, we're gonna be able to find out when it gets to the highest place. And if we can find when it gets to the highest place, we're gonna be able to plug that t in here and find out the position. Well, physically, what happens at the top of a projectile moving is, vertically speaking, it stops. It only stops for an instant, but it stops. And so what we do is we say, well, hey, what was this part B? So this was part A that we did. Let's look at part B. Hey, when does velocity equal 0? If we can find out when velocity equals 0, that's when it stops. So I just set the velocity equation, negative 32t plus 112. Set that equal to 0 and solve it. And I'll just subtract the 112 from both sides and divide by negative 32. So 3 is 96, 4 is too much. All right, I'm gonna do this completely without a calculator, then I'll do it with a calculator. So I'll divide these both by a negative and divide them both by a 2. So what is that? 55 would be 110, so 56 is 112, that's a 16. This is how I simplify fractions personally. If they're even, I divide them by 2. Divide these by 2 again, I get 28 over 8. Divide by 2 again, I get 14 over 4. Really? Well, don't I feel silly now? Divide by 2 again, 7 over 2. Is that legit? So this times 16, this times 16, 7 times 16 is 70 plus 4. Yeah, okay. So 7 over 2. Oh, that's a really nice number. It's 3.5. So at 3.5 seconds, it reaches its highest. So if I'm doing this without a calculator, I would say S of 7/2 is equal to negative 16, 7 over 2 squared, plus 112 times 7 over 2. And legitimately, you could have to do this. They could ask you to finish this on a multiple choice question on the AP exam. You could be required. So I'm just going to do the math real quick and show you how we would do this by hand and get a fraction answer. If you don't need it, skip. That's fine. So I have negative 16 times, so I have to do PEMDAS. I have to be careful. I do this exponent before I do the 16 times the 7 over 2. So when I square this, I'm doing 7 over 2 times 7 over 2, and I get 49 over 4. I'm going to clean this up in the meantime. Let's see. So 112 times 7 over 2. I can divide by 2, then multiply by 7. So if I divide by 2, that's what, 56. I figured that out earlier. So it's 56 times 7. And then here, Oh, so I'm doing 16 times 49 divided by 4. I can actually divide by 4 first because they happen kind of all at the same time in a row. So I could do 16 times 49, then divided by 4, or a different order. So I'll divide those and get negative 4 times 49 plus 56 times 7. So then I would have to multiply these out. Let's see, 49 times 4. So 4 times 40 is 160, and then that's 36. So negative 196. And then here, 2-digit times 1-digit is something that a lot of you should be able to do in your head. It's a good shortcut. It saves you some time. So 56 times 7. So so we're doing 50 and we're doing 6, both times 7. So 50 times 7 is 350. 6 times 7 is 42. So 392. Oh, so I'm just doing negative 196 plus 392. So I'm just going to write it vertically to save myself some time. So I'm going to write 12. That's 8 now. So that's 6. Oh, I got to borrow here. So that's 2. So that's 18. So that's 9. Nope. Wait. That's silly of me. I should have seen that. I should have seen that coming. 196. Okay. So 196 is going to be our position. If I was using a calculator to do all this, I might just use 3.5, and I would do negative 16, parentheses 3.5, squared plus 112, so it's 3.5. Oh, wow. All right, cool. So when you're doing your homework and stuff like that, I highly recommend doing fraction stuff by hand and then going back and double checking with a calculator. It is a worthwhile endeavor. AB calculus is when I got good at fractions because of all the practice. So it's when I stopped kind of being annoyed or afraid of them and just kind of accepted the reality of what they are. So for what it's worth, okay. Find the speed of the ball when it hits the ground. Okay, speed of the ball when it hits the ground. So we want to find the speed of the ball when it hits the ground. When does the ball hit the ground? The ball hits the ground. And so this is where, in the previous question, it asked, how high does the ball get? And we had to think about what actually physically happens. So when the ball hits the ground, sure, the ball stops, but we're pretending that that doesn't happen. It just hits the ground, maybe goes through the ground, and keeps on going. When the ball hits the ground, what is physically happening? Okay, well, it's going some amount fast. I don't know what that is, but I can say, oh, when it hits the ground, that means its position is 0. So I actually want to go and say, hey, when does position equal 0? And then I will solve this and find out what t equals. And I'm doing that because I'm trying to find the speed when the ball hits the ground. So I'll just find speed after I find out what time it is. So here's the thing. Some people are going to want to subtract the 112t from both sides. That's not how we do this. If you know how to solve this, like, don't let me solve it for you. Solve it your own way, and then see how differently we do it. I want to divide both of these by, if I divide them by 2, that's 56. If we divide them by 4, that's 28. Doesn't 16 go into 112? Oh, that's not helpful. All right. So, all right. I'll spare you. 7, okay. All right, so I'm gonna divide both sides by 16. Actually, I'm gonna divide both sides by negative 16. And I'm gonna get 0 is equal to t squared minus 7t. Then I'll factor a t out, and I'll get t is equal to 0 and 7. And so it says the ball touches the ground at t equals 0, and the ball touches the ground at t equals 7. And that checks out. If you think about it, we started out on the ground. When t was 3.5, we were at our peak. So in case you didn't know this, time up is the same as time down on particles, or on projectile motion. You don't have to know that though. So here we go. Let's find the speed when t is equal to 7. So let's see, what's velocity of 7? Negative 32 times 7 plus 112. All right, I'll spare you again. But I seriously recommend doing stuff like this by hand, taking the time to put your brain through those paces. You will benefit from it in the long run. You'll get faster, you'll get more accurate using the calculator as a backup, not a first resort, last resort instead. Use it as a last resort. Okay. I got my V was negative 112, but it asks for speed. Whew. Ultra challenging to do that. I got my speed is 112 feet per second. All right, so I know it was a long time going through that question. There's a lot of important stuff that we covered there. So 6 is all right, I'll go. I'm not like in love with 6. I think it's an interesting question. I don't think that it brings anything new to the table. I don't think that it's really necessary for me to go through it, but I'll do it. The equations for free fall on the surfaces of Mars, Earth, and Jupiter, S in meters, T in seconds, are Mars is that, Earth is that, Jupiter's that. How long would it take a piece of equipment initially at rest in a stationary orbiter and dropped to reach a speed of 44 meters per second? So we want to know when the speed is 44.7. So like literally, if I know my position for Mars is negative 1.86 t squared, well then speed has to do with velocity. So I could say, well, my velocity then is negative 3.72. And again, I did that in my head. Let me just double check. Cool. So negative 3.72 t. And we want to know, oh, but this is speed, not velocity that we want. We don't want velocity, we want speed. Well, okay, we'll throw absolute value bars on it. Like that's all. So when does this equal 44.7? So the thing is that, we're taking the absolute value of it. We're just using regular 3.72. So you would literally just go, oh, okay, 44.7 divided by 3.72, 12 seconds. When we are using our calculator, I want to remind you, we do 3 decimal places. That is not up for negotiation. You do 2 decimal places, you will lose points. And then I will mention to the entire class, hey guys, some of you for some reason are still doing less than 3 decimal places. Happens every year. And like, I'll ask the class, there, I took the derivative of that, I got negative 9.8. Doing the same thing, right? 44.7 is equal to negative 9.8 t. Wow, 44.7, 4.561 seconds. Someone just says 4.5 seconds. And I'll go, cool, you're not right. That's wrong. And my favorite, I love pretending like 4.5 is so wrong. Like that's one of the few times that me as a math teacher, someone would be like 4.5, I'm like, wrong. It's so mean, but it's just like, no, you got the right answer. You are smart. You just are not thinking about the requirements for what we do in this class. Because this requirement is totally arbitrary. Okay, This is crazy though. Think about that. If you, so 44.7 meters per second is approximately 100 miles an hour. In free fall on Earth, it takes 4.5 seconds to reach 100 miles an hour. Wish my car was that fast. All right, let's see. Jupiter. So Jupiter, negative 11.44 t squared. So then v of t is going to be negative 22.88 t. So if I do 44.7 divided by 22.88, I get 1.953 seconds. And I just want to remind you, this is an acceptable answer, even though you probably wrote 1.954 seconds, assuming that I'm correct and that's the actual answer. If that would be the answer, most people that I know would round that to 1.954. There's an argument to be made that 1.953 is a more accurate or more appropriate answer. And the College Board was like, yes, either one's fine. So. All right. A rock thrown vertically upward from the surface of the moon. All right. This is more of the same. I am going to stop here and you let me know though what questions you have. I want to help you. I think it's more beneficial for you just to jump over and start doing the homework problems from here. Remember that all the answers are available online. And yeah, have a good one. Bye.